11th Chemistry, Unit 4, Chemical Bonding and Molecular Structure, and in this video we will discuss about concept of resonance. Resonance structures. In the previous video, we have learned how to write the Lewis structure for a molecule. Okay, a single Lewis structure of a molecule is not sufficient to describe its experimentally determined parameters. For example, ozone, O3. For ozone, we can write these two Lewis structures. Okay, you can see what are the differences between these two Lewis structures. In this oxygen bond length is of 148 picometer, while in this case, this oxygen double, this is a double bond length is 121 picometer. Okay, now in this bond length is 121 picometer, and in this bond length is 148 picometer. The normal oxygen single bond length and oxygen double bond lengths are 148 picometer and 121 picometer respectively, but experimentally determined oxygen bond lengths in the ozone molecule are same, and that is equal to 128 picometer. This equivalency in the bond length is explained on the basis of resonance concept. According to the concept of resonance, whenever a single Lewis structure cannot describe a molecule accurately, a number of structures with similar energy, positions of nuclei, bonding and non-bonding pairs of electrons are taken as the canonical structures of the hybrid, which describes the molecule accurately. Okay, actually this is the hybrid which exists and explain the molecule accurately. And these resonance structures or resonance is represented by a double-headed arrow. This represents that this one and this one are the canonical structures or resonance structures for ozone molecule. But in actual, ozone exists like this. Both the oxygen bond lengths are equivalent, and that is equal to 128 picometer. Okay, this is the concept of resonance. Now there is some questions. Explain the structure of carbonate ion in terms of resonance. Now, if you write the Lewis structure for carbonate ion, okay, and this Lewis structure can be written, or whatever the rules we already discussed. Okay, I am simply mentioning this Lewis structure. Now, in this Lewis structure, the single Lewis structure based on the presence of two single bonds. You can say this is carbon oxygen, this is carbon oxygen single bond, two single bonds, and one double bond between carbon and oxygen atom. This is a double bond. Is inadequate to represent the molecule accurately, as it represents unequal bonds. It is two single bond and one double bond. But in practice, all the bond lengths are equal. Okay. According to experimental findings, all carbon to oxygen bonds are equivalent. That's why for carbonate ion, we can write these three canonical structures or resonating structures. And this is the resonance hybrid of carbonate ion, which actually exists. Okay. You can also write these resonating structures. Now, in these structures, this is two negative charges present on whole molecule. Okay. You can also write these resonating structure like this. That is on individual two oxygen atom, negative charge is there. But again, see, the position of all the atoms are not changed. Number of bonds are not so changed, and number of lone pair of electrons are also not changed in all these structures. Okay, and this is the symbol for resonance hybrid. That is, this is the resonance hybrid of these canonical structures. And in this structure, you can see that carbon oxygen bond lengths, all three carbon oxygen bond lengths are equal. Okay. Now let us see one more example. Structure of CO2 molecule. The experimentally determined carbon to oxygen bond length in CO2 is 115 picometer. The lengths of normal carbon oxygen double bond and carbon oxygen triple bond are 121 picometer and 110 picometer respectively. Okay. So a single Lewis structure cannot depict this position, and it becomes necessary to write more than one Lewis structures and to consider that the structure of CO2 is best described as a hybrid of the canonical or resonance forms of first, second and third. You can see these are the resonatic structure of carbon dioxide. In this structure, there is a double bond between carbon oxygen. Okay, this is also double bond. And in these structures, there is a carbon oxygen triple bond, and this is carbon oxygen single bond. Now, in this case, this position of triple bond is changed. Now, this carbon oxygen bond, triple bond, and this is a single bond. But in actual, carbon oxygen bond length is 115 picometer, which is in between carbon oxygen double bond and carbon oxygen triple bond. That's why carbon dioxide is best described as a hybrid of these structures. Clear? And for the hybrid, we can't write the Lewis structure. You can also write these Lewis structures like this. These dots can be replaced by bonds. Okay, double bond. Now this is single bond, triple bond. This is triple bond. This is a single bond. Again, see, when you write the canonical structure, no change in the position of atom, no change in the number of covalent bonds, no change in the lone pair of electrons. Okay. In general, it may be stated that resonance stabilizes the molecule as the energy of the resonance hybrid is less than the energy of any single canonical structure, and resonance averages the bond characteristics as a whole. Resonance energy. The energy difference between energy of the resonance hybrid and energy of the most stable canonical structure is known as resonance energy. Actually, resonance hybrid exists. That's why that is stable. And resonatic structures are not existing. That's why they are not stable. Not stable means higher energy. Stable means less energy. That's why the difference between the energy of a resonance hybrid and most stable canonical structure is known as resonance energy. When you consider the concept of resonance, remember that the canonical forms have no real existence. The molecule does not exist for a certain fraction of time in one canonical form and for other fractions of time in other canonical forms. There is no equilibrium between the canonical forms. The molecule as such has a single structure, which is the resonance hybrid of the canonical forms and which cannot as such be depicted by a single Lewis structure. Okay, student, this is about concept of resonance.